Okay, so everyone remember how we were doing the reactions of metals and acids? This is just a quick recap for anyone who didn't really understand it as such, and to go through it a bit more in depth. So remember, we've got our general formula. We have our metal and our acid, which are our reactants, forming our products, which are salt and hydrogen. So if we're just writing this as a general form, just so you can get to see who gets to swap around, as I said, our metal works with our acid, remember always has a hydrogen. Our metal swaps with part of the acid, so M and A come together to form our salt, and our hydrogen gets booted out. So we have our different salts, different names. There are three that we specifically looked at in our sheets. So remember, different acids up here, so produce a different salt. So with an acid, it will always have a hydrogen in it, but this part, A, will be something different. So let's have a quick look. We've got hydrochloric acid, and remember we have one hydrogen and one chlorine atom, and they come together, and that salt, remember, different salts are different names. So for hydrochloric acid, produces chloride salts. We've got sulfuric acid, we've got two hydrogens and one lot of sulfate. This thing together, SO4. So one lot of sulfur and 4 lots of oxygen make our sulfide. So we have our sulfuric acid produces a salt called sulfate. Thirdly, the other one that we've got on the first sheet is nitric acid. So we have one hydrogen again and one nitrate ion. So a nitrogen and 3 oxygens, we call that together a nitrate ion. So nitric acid, the salt, nitrate. There's one other one I want to mention just because you'll be looking at it a bit later. It's carbonates. So anytime you see CO3, that together is called a carbonate. It'll make sense when you have to do it a bit later. So now moving on to our first part. So we have our word equations. Basically all we want here, we want to see our metal, we want to see our acid, we want to see our salt formed, and we want to see hydrogen. So with this, you don't need to write the chemical formulas. All you're doing is writing out the words. So the first part is only our word equations. So remember, we have our metal, acid, salt, and hydrogen. So if we go through the first question, it's probably the easiest. We've got calcium, and we've also got hydrochloric acid. So what these actually form, remember, we've got our metal, and we have to form a what type salt here. You can take a minute to rewind if you want, or just come along. So we've got our calcium chloride. So remember, a chloride salt is produced from hydrochloric acid, and we always put our metal first. So we have calcium chloride. And remember, hydrogen always gets kicked out. Remember looking at our general equation, metal plus acid equals salt and hydrogen. So I just want to give you a quick idea of what I mean by positive and negative ions. When we're talking about this salt, we're talking about these two ions being in solution. So what we actually do for that, we would write it as AQ, which you'll see on the bottom of the second page in part 2. So what I actually mean by that is looking over here. So as I said, for our acids, we have a generic form as HA. Basically, with an acid, we have two things floating around. So we have our hydrogen ions, which are always positive, and we have whatever other species we have is always negative. So positive always goes with negative, so we want a neutral atom. Sorry, we want a neutral compound. So if we're looking at hydrochloric acid, we have positive hydrogen, negative chloride ion. we have 2 hydrogens, so 2 positives, and 1 sulfate, which has 2 negative charge. So 2 positives, 2 negatives equals 0. And thirdly, we also have our single hydrogen and our nitrate ion, which has a -1 charge. So plus 1 minus 1 equals 0. So what this actually means when we make our salts is we have these things floating around in solution just like our acid. We have our positive metal ions and we have our ions from the acid. So the metal is always positive. Always positive, because it would rather give up its electrons and have that outer shell being full. I'll explain that a bit more in a second. And you will always have your negative ions always come from the metal. Sorry, always come from the acid. So we will always have a positive metal ion and a negative ion from your acid. So move along next to part 2.